Okay, so welcome to the second lecture of Mathematics for Minor Finance. So today we're going to continue on our path to seeing or recalling certain kinds of functions. So basically what we're going to do is first have a look again at what's a linear function, then we'll look at quadratic functions, which resemble basically or which are related to the quadratic equations that we already looked at the last time. I'll go very briefly into power functions, then we'll have a bit of a more extensive review of exponential and logarithmic functions. And then at the end, we'll discuss how to construct the inverse function to a particular function that we might be looking at. But let's start with linear functions. So here you see a linear function. So the general form, you remember, I'm sure, of a linear function is y equals a times x plus b. And here you see a graph of a linear function. So the graph of a linear function is just a straight line. Now the a and the b are two parameters. So the x and the y, of course, are the horizontal and the vertical axis in this graph. The a and the b are two parameters where this a actually has the interpretation of being the slope. So the slope means how steep is this line, so how fast does it increase as you move to the right. And the b is called the intercept. So the intercept, the y-intercept in particular, is the value of y where this line crosses the y-axis. So crossing the y-axis, that's the location where x equal to 0, right? That's the y-axis. So the height at which this line crosses the y-axis, that's precisely what this b parameter is. So typically, what we would, so I'll go to actually to the paper to do this, but the kinds of questions that we would like to answer involving linear functions is, well, suppose I give you some points, for instance, on the line, or suppose I give you the slope of the line and a point on the line, and those are basically the two examples that you see at the bottom of this slide. Can we then actually compute what this expression that we just saw, this y equals ax plus b, what this relevant a and what this b are? So let's just have a look at basically at question 1, example 1. So I'm going to switch to the paper to actually have a look at that. So what this question asks, well, suppose we know what the slope is, and we know what point this line goes through. So the question here is, we know the slope of the line equals -4. That's what the example is. Suppose we know this. And suppose we know that the point -2, 3 should lie on this line. So what does -4 mean? It means it's going down at a steepness of 4 units south for every 1 unit east, if you wish. And the point with coordinates x equals -2 and y equals 3 should be on this line. Can we then say something about what the equation for this line should look like? Well, we know in general the equation for this line must be of this form, right? Y equals a times x plus b. So the question is, what are the relevant a and the relevant b for this particular case? Well, remember this a parameter that actually measures the slope. So if I tell you that the slope equals -4, then we immediately know, oh, a equals -4. So that already leaves us with this simpler question. We know this equation for this line is going to be y equals -4 times x plus some b. And it still remains for us to figure out what this b is. Well, for that, of course, we need this other bit of information. The point with x equals -2 and y equals 3 should be on the line. So in other words, should be satisfying this particular equation. So let's just plug that in. We know that if we plug in y equals 3, so let's put in 3 here, it should equal minus 4 times the x that's related to that y, is minus 2. So minus 4 times minus 2 plus b. Well, let's solve that. Minus 4 times minus 2, minus times minus makes plus, of course. So it makes plus 8. So it says 3 equals 8 plus b. Well, what's b? In order to satisfy this equation, of course, b equals minus 5. So with these two bits of information, the slope equaling minus 4, the point minus 2,3 on the line, we can actually determine what's the a, what's the b, and that's basically the answer then to the question. So the answer is, well, the equation for this line is going to be y equals minus 4 times x plus b. Well, b is minus 5, so minus 5. And that's the answer to this question. So the other question, the second example actually says, suppose now we do not know what the slope is. We are not told what the slope is, but we do know, well, in this example actually 2, 2 is on this line, so x coordinate 2 and y coordinate 2 should be on the line. And the second point which is on this line is 4, 3, so an x coordinate 4 and the y coordinate 3 should be on this line. So let me now use actually the graph which I already, the axis at least, which I already wrote here. So if we know 2 points which should be on this line, right, let them just be in general these 2 points. Not necessarily trying to reproduce these 2 numbers, but these are 2 points. Well, there's of course a line that's going through these 2 points, so it should be something like this. So if I would have had a ruler, it would be perhaps even straighter, but this sort of captures the idea, I suppose. So of course, well, let's call this point number 1 and this point number 2. So as you can see, well, this first point, of course, has a particular y coordinate. Let me call it y1, and its x coordinate will be x1. And similarly, this second point has a y coordinate, I'll call that y2, and it has an x coordinate x2. And now what you can see is, as we move from in the horizontal direction, so as we increase from x1 to x2, how much are we moving? Well, let's just call this an amount of delta x. As we move delta x to the right, the line should move up by how much? Delta y. Of course, delta x is the difference between these x coordinates, it's x2 minus x1, and delta y is the difference between the y coordinates, it's y2 minus y1. So now we are in business, because this basically, if you remember what's the slope, well, it tells us, this a parameter, the slope tells us how fast does this line increase as we move to the right. So how fast is this? A equals the change in the vertical direction, the y direction, it's delta y, per amount of change in the x direction, which is delta x. Or in other words, let me now plug in what those changes are. The changes in the y direction is of course y2 minus y1, that's the growth in the y direction. In our case, actually, it's positive because y2 is bigger than y1. Might also be negative if y2 were below y1, of course, and we might get a negative slope. And I have to divide this by the change in the x coordinates, and that's of course then x2 minus x1. So if I know the x and the y coordinates of 2 points which should be on this line, then I can actually compute this a parameter, this slope. So that's what we're going to use here. We have 2 points, 2, 2 and 4, 3. The first one being the x coordinates of point 1 and 2, and the second number being the y coordinates of those 2 points. We can actually compute again the slope. So let's recall, so the general solution to the line that contains these 2 points will be by this form. y equals ax plus b. I have to figure out what a and b are. Well, a was the slope, so let's just compute the slope in the way that I just tried to explain. So a equals delta y divided by delta x. Well, how much does y change? Well, y is the second coordinate. It changes from 2 to 3, right? So it's 3 minus 2. This will be in the numerator here. That's the change in the vertical direction. And the corresponding change in the horizontal direction, well, this change occurs is going from the x-coordinate 2 to the x-coordinate 4. So the change is going to be 4 minus 2. What do we see here? Is 1 divided by 2, or a half. So the a parameter, the slope parameter, if these 2 points are on this line, should equal a half. So now we are again operational because we know when a equals a half, apparently this line looks like this. Y equals a half x plus b. And we have to figure out what b is. It's the only remaining question. So how can we do that? Well, let's just again plug in one of these points. So we know that the point 2, 2, so x equals 2, y equals 2, should satisfy this relationship. So 2, 2 is on the line. From that information, we learn that just plug in the 2, the y equals 2 on the left hand side. It should equal a half, this half, times the x, also 2 in this particular case, plus b. Or in other words, 2 equals 1 plus b. And I'm sure that you now see that b should equal 1. So b equals 1, and the equation for the line is going to be, well, a was a half, y equals a half times x plus b, where b equals 1 plus 1. And this is the equation for the line. Let's just check whether, well, let's perhaps check whether both points are on this line just to make sure. If I plug in x equals 2, I get here on the right hand side a half times 2, that's 1, plus 1. Y equals 2, so that's correct, it's on the line. Does it also work for the second point? So if I plug in x equals 4, a half times 4, that's 2, plus 1 is 3, so y is 3, and exactly that's what we need. So this combination of parameters a and b, a half and 1, are indeed appropriate to describe a line which contains these 2 points, the unique line actually, which contains those 2 points. So let's see whether that indeed works. So indeed, so the first example that I gave gave this slope and this particular 1 point, and indeed we solve this as y equals minus 4x minus 5, and same thing. Here was this picture. Essentially, we need to figure out from the information that these 2 points are on this line, P and Q here, they're called P and Q in this case. We need to figure out again what's the slope and what's the intercept, right, the B parameter. And here again is that same computation. So that was linear functions. So next bit will be quadratic functions.